Hello, everybody, and thank you for coming. I will get my slideshow started. Right, so I just wanted to report to everybody here a few things we learned as we were approaching some open challenges throughout the years. Just to give you my contact information, it's here. Feel free to screenshot, and I'll be more than happy to, of course, connect with you and continue talking about all of these activities and perhaps potential. So just a little bit about the state of higher education right now in the United States. Well, at least as of 2019. In 2019, there were 19.6 million students who attended. Out of those, there were 16.6 million in undergraduate programs. About 40% of the overall number, so 7.9 million were 25 or older. This is very much to be expected in graduate programs. However, whenever you have older students in undergraduate programs, things are a little bit different and a little bit more difficult in some cases. They're usually called non-traditional students. Our non-traditional students in general, they often already have several years of work, sometimes even 2 or more careers. I've had students in the past who had already retired twice. This particular person, he was approaching his 3rd career with IT. However, of course, even though he was kind of an exception, he was definitely not alone in having had some prior experience. Something else that it's extremely important to be mindful of is that non-traditional students have families. In some cases, they even have grandchildren. So whenever we assign, for example, projects or something along those lines, we do realize that we are not taking time away from football games or watching TV or volunteering at some other entity, basically because somebody has free time. We're actually having them focus away from their children, their grandchildren, their bills, their work. So it's important for us to maximize our effectiveness as instructors whenever we work with non-traditional students. And something that's always a truth that many undergraduate institutions rely on is that whenever you're dealing with undergraduate students, the best way to initiate them to the work world is through an internship. Well, that's not always possible. Since non-traditional students already have jobs that may not be in the field, since they may have families they need to attend to, and they can come to school only for a certain amount of time in the evening, for example. Internships are simply not an option. So just to give you a little bit of an idea also about the particular context where we operate. The University of Baltimore is in Baltimore, Maryland. We are a minority serving institution. And in particular, we're a predominantly Black institution. The average age for the entire institution for undergraduate students is 28. Graduate students, it's 33. So as you can see, our average is already in that higher bracket, and we are not even talking about really graduate students. Even whenever we are talking about our undergrads, 28 is the average. And in the applied information technology, which is the degree where I teach, I don't have the data. However, I would say that we are even going towards the 30. So it's extremely important, again, that we maximize what we do, the effectiveness of what we do. Our degree has 3 different choices. Students can go for the general track, they can go for application development, or they can go for cybersecurity. In either case, none of the opportunities that you'll see shortly will be precluded from them. So what's our approach in general in terms of pedagogy? First of all, traditional instruction usually works. Of course, you can certainly do lectures, you can certainly do projects, you can certainly do flipped classrooms or whatever works best synchronous, asynchronous. However, that doesn't always work for everybody. We have a lot of people who start very happily. However, after 1 or 2 semesters, they see that it's not really adding too much benefit, or it's not giving them that job preparedness that they're looking for. Something else that it's extremely important for us is that we take the name extremely seriously. Applied for us, it's an extremely important concept. It's a focal point of our entire operation in terms of education. Basically, the whole idea with these projects is to bring real life experiences to the classroom. We don't want to give them the projects that are at the end of the chapter. We don't want to come up with projects where they have to print out a box or print out a Christmas tree. Of course, we're going to have those as well to some extent, but very, very limited. We actually want to give them hands-on opportunities. And for that, we utilize the concept called project-based learning. Now, I'm going to skip over, I'm not going to read everything on these slides. However, you'll see that there are many overlaps between what the concept of project-based learning requires and what open source software does. In particular, whenever you want to create a good project-based learning, it tends to have 4 iterative stages where described here on the left. The majority of institutions relegate this project to the capstone and experience. So that's basically the last semester, the last year of the students stay in the degree. However, at the University of Baltimore, we're trying to expand that in the way that I'll show you in just a second. In order to engage students, we want to make sure that we pick good projects, and the ones on the right are lists of some good of what makes a good project. In particular, I'm going to talk about NASA Suits. NASA Suits is, or Suits stands for Spacesuit User Interface Technologies for Students. Very much like Wolfgang mentioned in the previous talk, companies do not always have the resources and time to explore every single new technology. So what NASA did, as they're preparing to launch the Artemis program, so bringing humanity to the moon as a launching platform towards Mars, they want to create a spacesuit that utilizes augmented reality to deliver information. And they opened this up to universities. So what our students created is called Argos, or Augmented Reality Guidance and Operation System. It utilizes the Magic Leap one. You'll see the picture on the top left. And the students created basically the systems that you see in the other screenshots. There are animations of what the system looks like, as well as a different ways of interacting, whether it's through gesture recognition or through voice control. The astronaut or the potential astronaut can interact with the system. The system consists of the Magic Leap 1. We're also opening up to the HoloLens 2 this semester. We have a telemetry simulation, which is just a server running Node.js, and then we have an IVA simulation, or basically mission control type system that's running on a tablet. Our students had a blast. The first year in 2019, we got to spend a week at Johnson Space Center. These are some pictures from that time. Our students got to work for a few days. In the central picture, you can actually see the space vehicle mock-up facility. That's where they have a mock-up of the International Space Station where astronauts train. So they got to work with real engineers in the real setting. Last year, we also had a blast. The students learned a lot. Even though COVID hit, we were still able to get some awesome opportunities out. Here on the bottom left, we met Mae Jemison, the first Black astronaut. Actually, it was her birthday yesterday. As we had to stop in-person activities, the NASA Suits coordinators managed to get our students on the bottom right to send a video to International Space Station with Bob Behnken, astronaut Bob Behnken, who answered a question from our student. We also did outreach with middle schools, as it shows on the top left, and we did a lot of hands-on opportunities in terms of research. So this is some of the feedback that we got from our students. They were extremely thrilled. And by the way, if you teach at a higher education institution, I highly recommend it. And the students are going to be absolutely overwhelmed by how important these kinds of projects are, these hands-on projects are. Overall, it was definitely a stretch for them. However, it wasn't too big. All of our courses cover the fundamentals. We decided to go a little bit further, so not just keep it for the original group of 7 students, but expand it quite a bit as time went on. So we decided to actually open it up to a few more of our students. And because the experiences reported by our members were so thrilling that we just needed to see if it's possible to get similar reactions. So what we did is we took 3 courses: object-oriented programming, database systems, and mobile applications programming. And we took bits and pieces of the original system, broke it down, and turned it into either individual or group projects. So basically, we took this open challenge with all the software, documentation, and whatever else the students had worked on, gave it to a new generation of students, and let them work on it. So this is some brief feedback, and I'll give you some information later. When we asked if these projects were more interesting than the typical, pretty much everybody, almost everybody said yes, absolutely. Some were kind of on the fence, of course, because I guess some people are very difficult to impress. However, the majority of our students were absolutely engaged in this with these types of projects. Of course, many had to learn a lot about the context, and that's kind of the main idea here, the main goal, to go beyond what the students learn just, for example, in databases. And besides, what group of students would pose for a group photo at the end of the semester anyway? And as you can see here, this is just our regular, in this case, a database course. So we had a lot of fun, a lot of interesting opportunities. And then as our students graduated, again, please screenshot away, we had, I asked them, these are former group members. Naji on the left is the one who sent the video at the International Space Station, Michael here on the right. After graduation, and again, we're a small university, we're a small school. He got accepted into a PhD at Carnegie Mellon. He is currently working on Amazon and turned down a whole lot of experiences everywhere because he decided to go for Amazon. Hannah here, she keeps getting calls because potential employers are absolutely thrilled. And Larissa here, she was part of the first generation. She actually got a job at NASA, or rather at a contractor with NASA. She started off coming from a community college and she wanted to do web design, and now she's working on spaceflight data. Another hands-on project that we have is called Green Basement. Green Basement is a little bit different in terms of a change of pace. This is very internal. We are basically trying to create a growth stations that we can utilize for our instruction so that our biology students can learn how to manipulate variables that affect plants, such as light, such as feeds. However, our long-term goals is to supply our fresh food pantry, as well as try to mitigate food deserts. Food deserts are areas that don't have access to fresh food. The map here on the right shows in yellow all the areas that do not have access to fresh food in the city of Baltimore. So once again, our students were absolutely thrilled with the experience. This is our little farm. You can probably recognize IKEA furniture. Raspberry Pis, Arduinos, was that what we used throughout the experience. We learned a whole lot. I'll share with you shortly a link or the title of the paper that describes all of this in a lot more detail. However, we do have quite a bit that we learned and quite a few changes that we are already making. So what did we learn in general? If students focus on interesting projects, they forget about what they're learning. They're learning a lot. It's amazing how much they're learning. They will solve problems without even realizing, and then whenever they reflect on what they on their presentations, you can show them, hey, this is what I meant whenever in lecture I said this or that. Non-traditional students, this is fantastic. This basically works as an internship because they have projects to talk about whenever they got called for that interview. And we are thinking about expanding this from just 3 courses to a lot more of the curriculum. Please do keep in touch for any updates about this. This is more about our work. I will leave this. This is our final slide. So if you want to screenshot these 3 papers go in a lot more detail about what I just described, and we are preparing one more paper that's hopefully going to be submitted soon. Keep in mind that a lot of our students also submitted their own papers. We have a student who created a whole simulation of a lunar landscape using data from NASA. It's amazing. Anyway, just please do get in touch with me, and I'll be more than happy to get you a lot of resources, or as many resources as I can get.